No, okay, you start.
So welcome to our presentation. This talk is about the result of this program, Google Summer of Code, last year at OSGeo. I'm Margherita Di Leo, she's Anne Gisla. So, Anne, you want to introduce?
So, Google Summer of Code is a program that has been launched.
The microphone doesn't work. You have to speak up.
Okay.
For the video.
Okay, I will. So, Google Summer of Code is a program that has been launched by Google 12 years ago now. And it's aimed for student developers of university age to write code during the boreal summer, so the northern hemisphere summer. So during around 3 months, mentored by open source developers. And then, yes, that's it. So the students apply in around April. They get selected by open source projects that participate to Summer of Code. They get paired to mentors, so each student gets at least one mentor that takes care of guiding him or her in the first steps. And on the Google side of the organization, Google selects which organization take part, for example, OSGeo, Debian, KDE, or other universities, other projects who have work on open source. And then the organization takes care of selecting the students. I leave.
So in this context, OSGeo applies as a mentoring organization. What is OSGeo? Is the Open Source Geospatial Foundation. That is an umbrella organization that groups most geospatial software, open source software that you can find out there. Most famous maybe are some of them like Quantum GIS or GDAL, which is beneath several software, but there are many more. For example, OSIM, for example, GeoNode, and so on. So we are
OSGeo just celebrated its 11th birthday yesterday. So we're very proud of it.
Thank you. So, but of course, if you want to know more about it, just visit our website. So OSGeo has participated to Google Summer of Code since it began, basically, because we have participated. We have applied also this year, and this is our 11th year. And here we present our statistics about our participation. So this is the number of students per year, and the student that passed the program. So we did quite good, I would say. So this year we also plan actually to apply also to a similar program that is targeted to high school students. That is Google Code In, because we saw that we can get such good participation, such good outreach to young developers. Maybe it's time to address also the younger generations. And so we put up in place a broader team of administrators. So for this year, we are not only me and Anne, but we are 7 people taking care of the administration staff for OSGeo. So last year we got 22 students accepted, and we asked the student to describe their own work in their own words, because of course they have their own mentors. So we are not here to explain in detail the work that has been done, because we are not competent about that. Our task is the selection of the students, taking care of them, but then all the work has been done by the students and by their own mentors. So here we present a list of the projects that have been developed and the description. So we gave them a template to fill, which is the description of the project. So in this case, the student participated with the GDAL, and is Javier Kumar Singh, mentored by the Rob Emanuele Evan Rouault, and he developed basically the support to OGR for some geometries that were missing. So it's a triangulated surface, polyhedral surface, and triangle. So he added those API to the OGR geometry. So we asked them to provide a description of their idea, and then the state of the project before the Google Summer of Code. So in this case, it says that according to the standard, there was no proper implementation for these three type of geometries. So the addition to the project provided by him, it's such modification. So here you can find also their last, this link, you can find also their last report, where there is also a link to the repository and all the documentation that can be useful for you to go into the detail. And here there is a graphical representation of his project. Of course, he represents the OGR classes, and he adds the one that he developed. So the second student, also for GDAL project, is Alexander Bordzik, but I'm sure I don't pronounce it well. So the description, he added the DWG support to the GDAL, and this was a long-wanted feature, because the DWG is a proprietary format, so it was hard so far to deal with this kind of data that comes from a proprietary CAD software. And but it happens very often that this kind of files has to be processed in GIS. So he added a support that is totally open finally. So the third student is for GrassGIS software, is Adam Laja, that completed the basic cartography suite in GrassGIS through the graphical user interface. So basically what is this is when you want to do hard copy maps, you need to put together the maps in a way that look good to the eye. So he developed the graphical user interface to do that. So here is an example. There is the legend. There is the north. Oh, sorry. Okay. So the addition to the project, he mentioned these commands that were previously only via a command line, and now they have a proper graphical user interface. So another project for GrassGIS is developed by Andrei Pezek. that is a PyQt implementation of the graphical user interface, generated automatically from XML. What does it mean? GraphGIS has a graphical user interface based on WX Python, but this creates some problem because we noticed that it is strongly platform dependent in a sense that, for example, a Mac user had some specific related platform issue. So since the PyQt are a little bit more, let's say, used also from other software, and they are doing good, the community has decided that this is a good way, a good direction to take. So, in order not to, let's say, in order to maintain the graphical user interface totally separated from the rest of the software, this is generated automatically through XML. And it started with an implementation. This is really a big project, but he started and developed a good part of it. So another project another project for GraphGIS.
You have to say why there is no
Sorry. Okay, because we asked the students to provide their pictures, but they are not obliged to. So for those who didn't provide, we choose a picture. So there is a troll face. So this student developed another project for GraphGIS. Is Mayaka Agrawal, and the title of the project is WebGraphs. Basically what he did, he developed an interface, web-based graphical user interface for the software graphs. And this is very useful also, for example, when you want to give courses, because the installation can be sometimes tricky during a course, so you may want to skip this phase. But it's also a good way, for example, for collaborative use of the software. And this is how it looked like.
So I will go on with the GVSIC, Spanish GIS software, and we had one student, Carlos Columbano, who worked on GVS education project that was about creating automated tests that are, for example, used in a school environment, and teachers can fill up a template in an open document format, and this generates the associated maps that could be used as quizzes. And this is already used and it's committed to the source code. We had a second project that was done by Silvia Franceschi, and it's about hydrology in the mountain areas, and especially in wooded areas. And this project is about the modelization of floods in presence of wood cover, because the models that were available before are not so exact. So the actual runs of the model could not correspond to real situations. Now with this improved model, you have visualization of the actual stand and a better modelization of the flow. We have projects, students who worked on ISTSOS. That is a fairly new piece of software that is, this project focused, these and the next ones, focus on giving interfaces and joining it with other pieces of software. So, Florin Daniel Cholobok worked on an Android client.
May I add something about? I want to add only one word about our student Florin, who joined the admin team this year. So, after being a student last year, he decided to help us, let's say, reaching more students.
Yeah. Yeah, I forgot to mention that among the mentors, many of them, so I think around half of them, were former students. So we are very happy that there is this turnover of people who know what it is to be a student, know what a student could need in terms of help, and they are really the right people to provide eye-to-eye level help to new students. So this is the schema of Florin work. Luca on ISTSO's work on web publishing of ISTSO services, so a web API. And these are some of the visualization that is now possible with these tools, so some graphs. This is the configuration area, the map, and some of more compact visualization. Felipe Proveda worked specifically on charts that I show. No, I think it was a remote picture. I'm very sorry. It's present on our online presentation. I hope it doesn't happen. Gabriele Fresti Filippo worked with NASA Whirlwind, and Gabriele was actually member of the team of the previous presenter. So we're very proud that he's also present here with NASA. And NASA is actually not a proper OSGeo member as a project, but this is a big discussion of what OSGeo should do, as in certify software or being open to consider open source geospatial even software that is not under OSGeo hood. This is a big thing that is continuously being discussed in OSGeo. But in Summer of Code, we wanted to be open to any open source geospatial project, so we had every year guests in the sense of OSGeo, and we want to consider them as proper part of our group. And Gabriele made a web application that uses NASA Web Whirlwind framework as a base, and then adds plots, three-dimensional plots on it, and it's really fancy. We had one project on Open Layers 3 from Samuel Lapointe, mentored by Jessica Lapointe, that is not a relation, they said. And she was one of our students, for example, for a couple of years. And Samuel worked on the Open Layers 3 Google Maps library, that is the library that allows to overlay Google and not Google Maps. The problem was that when this library was used, the functions and the animation that was done on the maps was not consistent with the rest of the application, so he rewrote the library, sort of, and now the refresh of the map doesn't show these desynchronizations anymore. So this is what he did, as in the code, as in the... You see the visualization doesn't change much, but it's really much more fluid. We had one guest project, as in transit time, that is about public transport routes and routing. And Brendan Egan worked on a quick start setup for this application, because it is a very new project. So installing and running it is sort of troublesome for non-developers, and even for the developers, they were telling us. And so he provided this quick start that is also a demo, so one can also just use it to show, to see the functionality of this project, and or to set up his own instance on your own computer. And this is what you see. So you see, for example, a route for public transport with the stops, and each stops as proper information.
So this is another project for Awesome, developed by Martina Di Rita. She did with us more than 1 year Google Summer of Code project, and she completed a project of a complete photogrammetric awesome tool for the generation of DSM from SAR images. I think we should go a little bit faster. Yes, yes. 24. Yes. So this is how it looks like. But in the presentation, you will find all the links to find all the material related to all the project. This is a PG routing. PG routing developed two projects with two students. The first one, Andrea Nardelli, developed the flow algorithms for PG routing, that specific flow algorithms, not just routing. So this is a graphical a representation of it, and this is the second for PG routing, Sankepalli Reddy, implementation of a framework which supports addition of contraction techniques.
This project has a very nice explanation because you can simplify a graph. When a graph is very big, you can simplify all the segments that are linear with several nodes on it. You can compact the nodes in this short notation. This doesn't influence the connection of the graph, but it makes it simpler and smaller in memory, so you can... This is the other contraction that is implemented, so when there is another linear path with more nodes, they can be condensed in only one. And this speeds up computation a lot. PyWPS, Jan Rudolf worked on a web interface to start, stop, and pause processes that are run by PyWPS. So now you can actually do that. Those are the functionality that was not yet available. Akbar Gumbira worked on QGIS.
Sure. So he developed a plugin for sharing symbols and style symbols for maps for the user to share this kind of let's say resources. Yes. So here it is how it looks like. Finally, there are two projects developed within Zoo project. One is bringing the PyModis to the web through Zoo project. So this basically brings the functionality of a tool called PyModis that downloads and processes Modis to the web, basically, seamlessly. And the last one was actually a project not only for a Zoo project, but combining Zoo, JGrass tools, and GeoPaparazzi, that are three software, and this is a sort of binding between them. So if you received so much information, you can visit this web page to find out more. I just wanted to... okay. She just wanted to add.
We want to thank our Google administrator in the front, and you can find her and other Google Summer of Code people at the stand in Building K. So you're welcome to directly ask them. Thank you.
Thank you.